This week we are going to make a Ratchet wrench. We have 8 parts, as you see in the technical drawing part list. We have 9 parts, and we are going to just model 7 parts in our figure. We also have 2 bolts or screws attached for the mounting purposes, and we are going to model all the parts here. Here, what I'm going to do is I will just go to the next page. We have the parts actually here. We have 7 parts: the wrench body, the gear part, the part 4, part 5, part 8. Here we have part 7, I'm sorry. The other parts are the ball and the pin. They only have the nominal dimensions. We have a ball here with 4 millimeter, and we're just going to make correction here. We have a pin here. The diameter of this pin is 4 millimeter with the length of this is a cylindrical part, 4 millimeter diameter and 2.5 millimeters in length. I will just start the modeling. We have a sectional view here, media sectional view. We have some dimensions in our figure. And the first thing, what I'm going to do is I will just create the model of the wrench body. I will just zoom in and have a look at our part here. We have a draft angle projection here. As you see, when we have an extrusion, this extrusion goes sideways. As you see, we have a 7 millimeter draft angle according to the extrusion direction. This is our extrusion direction, and we have 7 degrees draft angle starting from the center point. Here, what I'm going, as usual, I'm going to just create a first sketch which is seen about our part. What I'm going to do is I will just create a new sketch just representing the main dimensions. Then I will just create some dimensions and other things according to the our figure. Again, I'm just going to just adjust my sideways. I will just take the left side our figure and right side our inventor software. I will again adjust some dimensions. Open a new part. This is a metric part. Actually, it was an inch part, so I have changed the dimensions of these parts. I will just start a new part. 5. As usual, I'm just going to select a center point for my figure, and I will just choose this point as my center of our wrench body. I will just save. Oh, sorry. I'll just choose this point as my sketch origin. Save my part file to the desktop. I'll create a new folder, Ratchet, wrench. Sketch. The part 1 branch body. Enlarge this folder just to see the visibility of XY plane, to open the XY plane and center point visibilities. I will start a sketch on XY plane. The first thing, what I'm going to do is I will just create two lines representing this center line axis. So here, I will just create two lines arbitrarily, having the horizontal and the vertical constraints. As you see, we have a horizontal constraint, and as you see, we have a vertical constraint. Here, I will just make coincident this line at the origin point and this line at the origin point as well. What I'm going to do is I will just create the dimensional relationships. These those lines I'm not going to just use. For this purpose, I will just convert them by having the right click and have the construction issues. I will just create one axis for this axis. You see, we have another center point here. Also, we have two bolt interfaces here. I'm also going to just create a new line and make this line as construction and make the midpoints of these lines on these points. Here, what I'm going to do is I will just create the first dimensions, which is 12, this dimension, and we have a 19 from the point of origin here. 19 here. I will just clear the annotations which I have done so far, and I will just go inside. So inside to see, to show you better what details we have. We also have some details. As you see, we have some dimensions, relationships. Actually, I have realized that I have forgotten. We have also the bolt center dimensions are 19 millimeter far from each other. What I'm going to do is I will just create an axis having a center point with the radius dimension. Right click. I have 16 millimeters. This is the dimension which I have seen here. This is the dimension I have created so far. The next thing, we have another point here having these dimensions, also other critical dimensions. We have a 16 and also some other dimensions so far. 19 millimeters, we have a very much in thickness. We have 13 here, we have 19 here, and the offsets for all parts which are just have those dimensions so far. Also, we can take these dimensions from the part of the cover of our branch body. Here, what I'm going to do is I will just create other axis, which is 19. So I will just go zoom in and have this line, intersection, and I have this side. We have the diameter, it is 19. And from the branch body, we have an 11 millimeter radius and 14.2 millimeters. This is the body dimensions, and these are the cover dimensions. Also, we have some other details here. I will also adjust this one with this dimension with the dimension radius 13.2 with the radius side. And these lines, these circles are connected to each other, and we have a parallel dimensions. These are the offsets of our body parts. I will just clear. This is the other outer dimension here. I have a tangent condition at this point. I will trim. And also we have 14, this is the 16, but we have 14.2 inches. I will just create 14.2 inches with radius dimension. This is my 14.2 dimension. And also I will just delete this one. Also for the inner part we have 11 with radius. Also these two circles, this one and this one, are connected with a tangent line. Again, tangent, this line to this line. We have just trimmed the unnecessary parts. So this part is also unnecessary. We also have another dimension, as you see. We have 16 with 14.2. And for this, between these two circles, we have a distance about 1.8 millimeters. For here, I will do the same thing for this circle and give this dimension, which is 1.8. 1.8. Also, we have another tangent line between these two circles. We have a trim dimensions. We have the same other side dimensions, but I'm going to use the mirror command for other circles. I will use this line as a mirror line and take to the other side of these two lines, tangent lines. I will use the mirror command, select this line, with the mirror line, this line, would apply and down. We have all the body parts so far. I will just make the trims for unnecessary parts we do not need. I will only keep 13.2 and 19 millimeters to insert. Here I'm going to just trim. Also this one I need. This intersection I need. This intersection I do not need. I have lost this dimension, which is 13.2. I will again supply that dimension. I will keep these two lines. The rest of the other lines, I will just make the trims because I do not need the dimensions. These lines into it. I will just clear my sketch and this also this one. This one and clear the text. Just clear the extension here. Third. Okay. Extend. settings. Again, I will give the dimensions that I have. This one, also this one. I do not have any dimensions. Okay. This is a dimension. I'm sorry, I have just made a mistake here. I will just make a trim. Also, this one I'm not interested in. I will extend this circle, and make the trims for unnecessary parts. This is the internal feature, this is the outside feature. Also, we have two small circles which are here. As you see, we have two small circles. Also, we have two other small circles in this one. The dimension between these two circles are 19, but they are symmetrical around this line. This point and this point is symmetrical around this line. And the dimensions of these holes are 4 millimeters. Also, I would like to just make equal for the other side. We have the 13, and we have a 8 millimeters surface here. This is the 8 millimeters so far. This is a 8. This belongs to this one, and this belongs to this one. We have all other details for our wrench body. From this point, we will have a continuation. From this center axis, we will just go 85.5. I will just draw two lines. Also another line for representing these two lines. These are the lines that will be used for our sketch. Here that we have the thickness for 13 millimeter between these two. I will give this distance 13. And as I say, it's moving around this one. For this, prevent this, I will just use a symmetrical constraint around this axis line. This is symmetric around this line. And I will just trim the unnecessary parts of this two lines. And this line is interrupted with a new line, which is 18.5, 85, 75, 85.5 millimeter far from this circle center. For this, I will extend these two lines, and I will just make the trims for our figure. The next thing, we have the handle part, and this handle part has a variation about its thickness side here, which is 18.5 inches, millimeters. I will just clear all my parts here, and I will just create, this time I'm going to use a rectangle, and I would like to keep the midpoint of this rectangle at this point. And our rectangle shape is 76 millimeter in length, 76 millimeter in length, and its thickness is about 17.5 millimeters. As you see. Okay. We have just created our body part here. sorry, this portion. Okay. This is a sketch that we would like to just create so far. This is our wrench body, and we will just create the sketches so far. Here also we have a small thickness inside, which is 0.8 inches. For this purpose, I will just go inside, and I will just make an offset about this point. As you see, where I have just made a mistake, I will just correct it. Also this line, I will just offset, and this offset distance will be between these two lines, or 0.8. Okay. This is our wrench body sketch so far. Finish my sketch. What I'm going to do is, the head of this wrench is 14.3 millimeters. I will select every single item in our sketch. For this, I'm not going to disturb with this one. I will just create a new sketch on XY plane and take the out geometry of these circle body, which I have just created the projection. I will just use this sketch for extrusion purposes. Again, I will just right click and open the visibility. I will again use these two lines and the rectangle on the end of this part. What I have done so far is this one. I have just created three different sections. Also, we have three different sections, which is the head part is 14.3, the middle part it is 8, and the handle part it is 11 millimeters. We have all our details on the sketch. For this, I will just simplify the sketch for extrusion, the sketch that I'm going to use in extrusion purposes. Finish my sketch. I have the extrude tool. I will select the head part and I will use a symmetric condition. This time I'm not going to use, I would like to keep my sketch on this surface between these two surfaces. I will use the symmetric condition and change my dimension to 14.3. When I use this sketch in an extrusion, in a feature, I will just lose its visibility. To use it again, you have to share by having this visibility option on. Again, for the midsection, we have, again, I'm sorry, I have made a mistake. For this extrusion, we would like to just create a taper degree to have a shape with a draft angle. This is for the forging and also casting purposes. We have just created these angles to just cover from the molding part from easily after the casting or the forging purposes. Here, what I'm going to do is I will just make a taper with a draft angle. It is called normally with 8 degrees here. To show you what I'm doing is, as you see, I have just increased from 0 degrees to 7 degrees. But this time, I am enlarging this top surfaces. For this, I will use the flip down direction. For here, as you see, we will just make the extrusion to inside with the draft angle, which you have seen in this point. As you see, we have a draft angle to outside and draft angle to inside. As you see, you can also give this flip direction with -7 degrees. Okay, I will just use again for the midpoint. I will use this midpoint, and the thickness of the midpoint here, it is 8 millimeters. It is an 8 and 8, 7 with a draft angle with symmetric condition, and I will change the direction of this flip to inside with OK. Next thing, what I'm going to do is, as you see, when you just give the draft angles, the connection between these two items got lost. We will just heal this portion by filling a normal extrusion rather than the draft angle here. We will just complete these items to be not too drafted. We can also use this draft angle for giving the draft angle properties to our solid. For this one, we are going to use last section by this draft tool, by using this draft tool. We have, as you see, we have 11 millimeter in thickness, the last handle point. I'm not going to use a taper angle. I will use the draft angle, this surface, and this surface. As you see, we can just give draft angle. I'm sorry. Again, just choose. This is the fixed edge. This is the fixed plane. We have many options. The parting line. I'm going to use this one. The parting surface here. It is the parting tool, and the pull angle direction to inside or outside. The faces that I'm interested in is the inside. As you see, it is just going outside. The inside with 7 degrees. I can just change the direction to inside or outside like this. Okay. You can just choose the symmetry line. Again, 7. You can also change the angle here by giving the minus sign. Anyway, for this, I'm going to use 11 with 7 by using the flip direction tool. I will just heal the parts separated from here by having the extrusion length about this features here. Starting your sketch on this surface with F7 tool, I can just create a new rectangle tool just to heal these two portions. I will use these portions to heal the connection between these lines. Also, I'm sorry, I will just take one back. I will use these geometries to heal the sections between the items. We have some other tools. We will just create a circle tool. Also, I would just like to have a line. I will use this cross line tool to heal my figure, which I have C from this point. I will use this point, this line here, here. I will just trim unnecessary parts. I will use this first outline. I will use this portion for extrusion purposes. What I'm going to do is I will just create an extrusion tool inside. I'm sorry. Again, I will just use trim unnecessary parts. We have 7 tool I will use inside figure here. Extrude tool. That's the first sketch using these. Extrude tool. Something upon this. We have 7 tool. It's closed. This is not closed as you see. Project geometry. I will just close this one. And this geometry will be closed. Trains operations. Okay. Now the extrude tool. This time I will just heal the connection between these two portions. Okay. Next thing, we are using the tool section up to XY plane. To XY plane. I will just check to fill the gap inside. This time I will use the 7 tool. Minus 0. Let's keep this distance to be 8. I'll just connect these 2 lines. Or you can just make a new extrusion between these 2 items. We have just done this time separately. We can just, for these connections, we can just create F7 tool. We can just connect 2 items. And this time I will just redefine and move this section to inside. We have the extrusion tool, and I will just heal the gaps, which is 8 millimeters. It's symmetrical with the draft angle 7 on each side. Just flip the dimensions, and I will just heal the connection between the items. As you see. When I just gave the extrusion here, we have just made lost the connection separately. For this, I will just create a new extrusion to heal this connectivity. I will just use 2 rectangles to just make them connected to each other. The next thing, what I have is, I have a fillet on each side, as you see. I will just use the fillet tool. I will change the dimension to 25. And this one, as you see. Also this one, you see. On the other side, it's not implied. Do that out. Also this one. 2 fillets. When we look from the top side, we have 2 fillets. The next thing, we have the geometrical items, which we have just created. For this, first of all, what I'm going to do is I will open my first sketch and make the first inside feature here to make it empty to inside, which is 13.32, I'm sorry, and 90 millimeters. What I'm to see better, I will change my view from the view tab to the half section with the XY plane open. The next thing, I will just clear everything inside. I will just have an extrusion tool. I will just create an extrusion cut. This time cut with a true all section. But this time I want to be sure that everything is to be clear in my section. I will change half section view to end section view. As you see, we have an outline in our figure. Here, what I'm going to do is, I will just again use the same sketch feature here to have the outline which our cover just sits on. For this, I will just start a new sketch on this face and hide the body to see my sketch here and have the geometries. This is the circle for our body part. I will just get these parts. Okay, we have a thinner inside and the outside for our figure. We will just finish my sketch, open my second visibility body. I will just create that sketch on this surface. And I will just create a new extrusion tool, and this time we have a 3 millimeter in thickness for our body part. I will use this figure with 3 millimeter in thickness and change my direction to inside. It will just make a cut for my purposes. Okay. The next thing, what I need is, we have 2 holes on our figure. Again, do the same things. I will just start an extrusion. Use this 2 circles with symmetrical and through all, but this time I'm just going to make a cut purposes to make again, symmetrical condition to have also a hole on the back side as well. Okay. The next thing, I have 2 holes for both connections, and these are seen as you see. We have 2 small holes, but the holes start from back side for figure. For this, I will just start a new sketch on the back face. I will just hide the solid body visibility, project the geometries to get the points on the back side of our part. I will just create 2 holes, this point and this point. We are starting with a countersink, and our dimensions of these holes, as you see, we have 7 millimeters with 82 degrees. This is 7 millimeter in thickness, the dimensions. It is not 90, 82. And our hole dimension, as you see, we have in this figure, we have a whole 4 millimeter in dimension. That is 4. Okay, the next thing, what I need is, I have some details about this part. As you see, we have a whole feature. Also, we need to just simplify this figure up to the somewhere here. We use the midpoint, but we would like to be sure about if this is 10.3 millimeters. What I'm going to do is, I will just begin at the half section. At this time, I will use to see the XZ plane to just check my figure. As you see, we have some missing dimensions. When I compare these two figures, as you see, we have missing cutting point here. For this, I will just create a new extrusion up to from the top point up to this point. Again, I will just create a new sketch at the top of this one, and I will use the same geometry which I have so far. As you see, I will just close my sketch visibility and have all the sections to be extruded. This section, this one, and to be on the back side, and point 3 with a cut properties. Okay. Next thing, what I need is, we almost done this part. We have a 3.50 millimeter far axis up to this point. We have a 4 millimeter in diameter hole, which is for 16 millimeter far from this one. For this, we have two options. You can just create a new sketch and have the revolve tool. For here, I'm just going to use this line and create a midpoint line. A line passing at the midpoint of this projection geometry. It is at the center point of our figure. I'm not going to use these lines. Also, construction. We have a line. This is our center axis line. I will just delete. And this center axis is 3.15 millimeter far from this bottom line. It is 3.63. I'm sorry. I will just use this endpoint to give this line 3.15 far from this one. As you see, it is not a horizontal. I will just use this vertical. I'm sorry. This horizontal line, and I will use geometry, something like this. You can also create a geometry, something like this. Also, you can just use mirror tool, using the mirror line. You can just engage this point on this line. As you see, the midpoint, the angle here for the drill angle, which is 11.18, and we have a dimension for, as you see, we have a dimension with 4 millimeter, which is this one. We have a 4 millimeter diameter. Now drill goes to 16 millimeter far from this line. We have that line, and this line is 16 millimeter. Also, it is just up there. Here, I do not need this part. This is a solid part. I have not converted to construction. I will use only this section. For this, I will just make the pins, some dimensions. Also this one. Also convert this line, this to lines, construction. I will use this outline to be revolved around this axis. I have the revolve tool. Select this profile. Do not forget this one. Now this line, and I need a cut to revolve process of our figure. Okay. Next thing, just I'm going to check if I have just mislead some parts. So far, we have done everything on our part with our draft and we have no part left. I will just use the wrench body tools. We all have the material for steel parts. For this, I will use a steel part property from the steel, from the library parts. I will use steel and change the body representation with, sorry, this time red. I'm going to use this tool as a red one. Okay. I will save my part file body. I will use the endpoint and section view and close the XY plane and XYZ plane visibility. Okay. The next thing, I will just save my part. The next part, we have the gear part. For this gear part, we have to use the library parts. We have a gear tool with 24 teeth with a face width 6.35 with the diametral pitch 25.1 1327. Here, what I'm going to do is I will just create a new file, and this file will be about the standard millimetric assembly because we just create the design features like the gears, shafts, and other things. It is just coming from the parts from the assembly environment. Here, what I'm going to do is I will just create a design tool and save this file as a gear set. Okay. I will use the spur gear tool, like this one. And from this one, I need a gear with the module here. Also, it is not a millimeter part, it's a DP part. For this, I made a mistake. I will use the English template, English standard millimetric inch here. Again, save my gear set on it. Design tool, spur gear. I have just converted this diametral pitch dimension. I need a gear with 24 teeth with a face width 6.35 inches. This is the millimeter, and I have to divide this one with 25.4 millimeters. Okay. Also, you can just create only with millimeter tool. For diametral pitch dimensions, I'm going to use this number 25.13, 25.13, 26, 27. I'm sorry. I will just calculate. We have some warnings about the design failure, and it depends on our figure, which we have the calculation, but for the geometry, we do not have any ambiguity here. I will just use this time the spur gear. This is the spur gear one. We have just used the gear one tool. I will just save this part file differently, part two with gear. Let's see. The display name, it will be just different. Hit OK, accept. I will just create two circles, two gear sets. Here, left click, I have just created one. I'm not going to use the biggest one. I'm interested in a smaller one. As you see, we have a 10 gears. We're gonna measure the side by side to this one. It is 0.25. When you have changed your dimensions from the document settings, as you see, the millimeter tool, when you just measure these tools, as you see, it is 6.35 millimeters. Here, I will just save my part. Here set, as you see, we have also saved another part here, and I will use that gear set for modeling purposes. I will continue on that part. I will go for it. Just choose my gear set. As you see, we have a part wrench body, we have a gear set, we have a gear part. I will just copy this file to my folders, and I will just use this one. I will close this gear set. I'm going to just model onto this part. I have the gear set here so far, and I will just create. We will just create a straight wall here. Also, we have some 4 millimeter thickness and 4.8 millimeter in thickness here. We have a diameter with 13 millimeters. I started a new sketch on this one. A circle here. It will be 13. And this time I'm going to change from the tools menu. I will just change the standard to ISO because I'm going to just use the millimeter kilogram with SI units, which is this one, 13 in millimeters. As you see, let's finish my sketch. I have the extrusion tool. As you see, it is in 4 millimeter in thickness for this side. And I need an asymmetrical side. It is 4.8 with the thickness 6.35, which will just pass through this part, as you see. When I just measure the faces, as you see, we have 4.8, which is this one, and we have 4 millimeter from this side. We have 4 millimeter of this side. The next thing, what I need is, we have a square bolt here. As you see, we have in the body part, as you see, when you just go for it, I'm sorry, that's not the hand tool. Okay, we have a square at this point, and we have a spring and the other parts. I will just create those parts for our figure. I will start a new sketch on this one. For here, we have again a square dimension to be. I will use this time a rectangle with 2-point selection. I will use the midpoint here. I use 9.2 millimeter, and this time to be square, I have to equalize every corner about our figure. I will just finish my sketch. I have the extrude tool with 11.2 millimeters. I'm sorry. I have the extrude tool 11.2. This one. I would like to just create, as you see, we have a cross section at this point. I would like to just use the XZ plane for this figure. You can use also any other plates, YZ plane or XZ plane to just create this revolve tool. You can also use some tools, but I'm going to use a revolve tool for my sectioning purposes. I will create a new sketch on this plane with F7 tool. I will just create two rectangles starting from this point like this. I will convert one line to center line, not construction, center line. And I will use the tools here, which is 4 millimeter. This is also 5 millimeter. And this tool will just start, this distance is 8 millimeter. And I will make the cut run around this point. As you see, we have another distance. The center line is, I'm sorry, this tool, I have the distance with 6.35 millimeter far from finish my sketch. I have the revolve tool. Yeah. Every section I'm dealing with. This time I will just make a cut around this. This is the part for our gear set. I will save this one. The name that you have seen here, you can also change this one by copying the project part number, like part gear set. And you save, you will just get that tool and reopen, or just recall your part to the assembly part. What I'm going to do is I will just close this one and save this one. The next part, we have a ratchet part here. You can also see the parts, in the ratchet, what this ratchet do in the normal assembly. It will just make the sound also. Just you can use this for directional purposes of the working of the ratchet wrench. I'm just going to open a new part. This time I will just go to metric part again, standard with millimetric. Okay, this time I have forgotten one part to make the steel. Oh, okay, it is the steel part. This time I'm going to change the color to yellow. Okay, say the part 3. I'm not going to use this one. This is part 3 with ratchet. Open the XY plane center point visibilities, start a new sketch, add 2 lines, convert these lines to construction and next stick to the origin point. Okay, I'll change it by side. Okay. I will just make as what I have seen in this technical drawing. I will first create a new part file, also create a new line. For access purposes, I'm going to use this line passing from through this one, which is 25 degrees. We have an outline which is 4 millimeter, these fillets, and also we have an outline which is 19. This is my part. Also we have the curvature, as you see here, with 6.5 millimeters. For this, I will use a art here with the radius which is 6.5, and it will just go inside of our figure like this. I think it is not measured, but we have a distance about this one. I forgot that probably. I need a point to be dimensioned. As you see, we have also split this one. Give a dimension between these 2 points. I have to make it, I think it is 2 millimeters, something like this. Yes, actually I've forgotten that one. I will use this portion, it trims. I will use construction trim. I will take the dimension to inside the trim tool. I will use again the dimension tool. Take the other side. It's symmetrical. The mirror tool. I will use these two geometries by using the other side. I will just make the trim, get this dimension, and this dimension I will change the dimension style. I'm sorry, not radius style, the diameter type, which is 19. Also, I would like to make equal these two lengths. Okay. The next thing, what I need is I need these two circles and one rectangle with this option. As you see, we have 6.5 for this rectangle and 3 millimeter in thickness. Also 8 millimeter in diameter, which is this one. Also, we have, I'm sorry, we have some cut sections around this point, which is 85 millimeters. I will just create two lines. Actually, one line so far. Here, what I'm going to do is I will just make this dimension for 85, and I'm not going to use this one for trim. I have just trimmed. Also, trim for the other side. As you see, when I have just trimmed, you can just use sometimes the split. I need another line on the other side as well, and I would like to just keep line input between these two inputs. I would like to just keep the collinearity between this center, and then convert this construction. I need this line on the other side.